Hi, it's Mr. Guffick here, and I thought that in this video I would go through, or in this series of videos, I'm going to go through some of the most popular and important exam questions to know for Edexcel A-level maths. In fact, I say Edexcel, but this kind of question comes up on all boards. So this topic is called differentiation optimization, and in my experience, it's worth usually over 10 marks. And very often, students really don't know how to approach it. So let's have a look at what we're going to do. Now, what normally happens in questions of this type is you're normally either dealing with the area and the volume, or you're dealing with the surface area and the perimeter. And in this one, we're dealing with the volume and the surface area. Now, in questions of this type, they normally give you one of those two things. So they'll either give you the volume and you've got to work out the volume and the surface area, or they'll give you the perimeter. Now, in this particular type of question, well, let's have a look and see what it says. So it says, a manufacturer produces a storage tank. The tank is modeled in the shape of a hollow circular cylinder enclosed at one end with a hemispherical shell, and at the other end, as shown in figure 9. The walls of the tank are assumed to have negligible thickness. The cylinder has a radius r and a height of h meters, and the hemisphere has a radius of r meters. The volume of the tank is 6 meters cubed. Show that according to the model, the surface area of the tank in meters squared is given by that formula, 12 over r plus 5 over 3 pi r squared. Okay, so first of all, let's find an expression for the volume. So the volume of our kind of like tank, storage tank, is going to be the volume of the cylinder, which is going to be pi r squared h. And then we're going to add on to it the volume of the hemispherical shell at the top, and that is going to be 2/3 pi r cubed. So 2/3 pi r, 2/3 pi r cubed, yeah, because it's half of the volume of the whole thing. Okay, that's fine. So we've basically got, that's our volume, and we know that that is equal to 6. So 6 is equal to pi r squared h plus 2/3 pi r cubed. Okay, let's park that now and let's think about the surface area. Now, the surface area of this shape, I'm going to kind of like explode the shape into its constituent components. We've got the base, which has an area of pi r squared. That's our volume there. The base has an area of pi r squared. Now, this one sometimes confuses students. This distance here, people often get confused about. And what this distance is this circumference here. So if basically this shape was cut, if you imagine it was cut down there and it was laid flat on a table, that distance round there is actually that distance there. So it's the circumference of that circle. So that length is 2 pi r. Okay, and then we've got h there. So the area of the curved surface area of the cylinder is 2 pi r h. 2 pi r h. And then we've just got the surface area of the top, which is going to be 2 pi r squared. So there we go. There's our three components for our surface area. So let's write down now an expression for the surface area. So the surface area is going to be pi r squared plus 2 pi r h plus 2 pi r squared, which is going to be 3 pi r squared plus 2 pi r h. So that is an expression for our surface area. Okay, so we've got 3 pi r squared plus 2 pi r h. Okay, so that's good. So now at this stage, this is the feature that always happens in questions of this type. We're asked to show that the surface area is 12 over r plus 5 over 3 pi r squared. But this is what we've got. And the issue that we've got at the moment is that we've got a h in this equation. So we need to find a way of getting rid of the h from the equation so that we end up with what we've got there. And what we typically do is we take the equation for which they gave us the volume, we take that equation and we rearrange it to make h the subject. And then once we've done that, we're going to sub that into this other equation. Okay, so let's have a look at doing that then. So I'm going to write this equation down again. 6 is equal to pi r squared h plus 2/3 pi r cubed. So I'm going to subtract the 2/3 pi r cubed. So 6 minus 2/3 pi r cubed is equal to pi r squared h. And then I'm going to divide by the pi r squared h. So I'm going to have that h is equal to 6 minus 2/3 pi r cubed all over pi r squared. Let's break that down. So h is equal to 6 over pi r squared minus 2/3 pi r cubed over pi r squared. Okay, now that's going to cancel. The pi's are going to cancel. That's going to cancel. So I end up with h is equal to 6 over pi r squared minus 2/3 r. So I've now got an expression there for what my h is. And I'm going to take that and I'm going to sub that into this equation here. Okay, so let's see what we get when we sub that into there. So I've now got that my surface area is going to equal 3 pi r squared plus 2 pi r times by my h, which is going to be 6 over pi r squared minus 2/3 r. Okay, so let's do that. Now we're going to expand that whole thing. So my surface area is now equal to 3 pi r squared. We're going to have plus 2 pi, or let's expand it actually. So when I expand that, let's think about what's going to happen. So when I expand it, we're going to have 12, which looks rather encouraging. So we've got 2 times 6 is 12. The pi's will cancel, and we're going to have 12 over r. So when we do 2 pi r times by 6 over pi r squared, then what happens is that pi cancels, that r cancels with that one there, and we end up with 12 over r from that first term. And then from the second term, we're going to get minus 2 times 2 is going to be minus 4 pi r squared over 3, because we've got 2 times pi times r times by minus 2 over 3r. So that gives us minus 2 times minus 2. Sorry, 2 times minus 2 is minus 4. We get minus 4 pi and r is r squared. Okay, that looks good. So now we take our calculators and we're going to work out, let's have a look. So we're going to work out what is 3 minus the 4/3. So let's have a look at that. 3 minus the 4/3 is 5 over 3, which is super encouraging. So that means that this becomes now 12 over r plus 5 over 3 pi r squared. So that's our surface area expression done. And that's our 4 marks done for that first part. Okay, so let's just review the steps of what we did. So step 1 is they gave us in this question the volume. They told us the volume was 6. So we write an expression for the volume of the object, in this case, a storage tank, and we equated that to 6. Okay. Then we write down a second equation for the surface area. So we find an expression for the surface area, which is pi r squared plus 2 pi r h plus 2 pi r squared. And then the problem with this equation was it had a h in it. And what we were aiming for here in the question, the exam question, has no h in. So what we did is we rearranged this equation to make h the subject. Okay, and that's all of these workings here. So we rearranged it to make h the subject, and then we subbed into this equation here. And that eliminated the h. Now, this kind of question, this differentiation optimization, in almost every one that I've ever seen, this process that we've just been through for part A seems to be the way forward. It seems to be absolutely standard. So that's what's going to happen in pretty much all questions of this type. The only variant, as I say, is instead of it being volume and area, sometimes it's area and perimeter. So those are the 2 variants, okay? Now, usually in questions of this type, the part A is quite a lot of faff for usually 3 or 4 marks. And that algebraic, manipulation there, I wouldn't say is particularly the easiest thing in the world. And it's quite easy to make a mistake there if you're not careful. Usually, however, the part B is usually worth the same amount of marks, and is comparatively a lot more straightforward. So the part B is a lot easier. So let's look at part B. So it says the manufacturer needs to minimize the surface area of the tank. Use calculus to find the radius of the tank for which the surface area is a minimum. Okay, so we're going to now, and it's kind of nice in a way that they've done this question, because even if you did get lost in part A, there's like a break point, so you can like pick it up from here and continue. And I think that that's done on purpose to like help the questions be more manageable. So yeah, we're going to differentiate this because we want to find the value of R that minimizes the surface area. So we're going to differentiate our area with respect to R to get dA by dr. Now, it might be worth actually rewriting that A just to help it to be easier to see what it is when we differentiate. So I'm going to write A is equal to 12R to the minus 1, because I think that it looks easier when you see it written down like that from a differentiation point of view. So dA by dr is going to equal minus 12 over R squared plus it's going to be 10 over 3 pi R because we've got 2 times 5 there. Okay, so that's been differentiated now. And when we've got a minimum, that is going to equal 0. So we're going to put that equal to 0. I'm going to take the 12 over R squared across to the other side. So I've got 10 over 3 pi R is equal to 12 over R squared. I'm now going to multiply both sides by R squared. So I get R cubed is equal to 12. Actually, I have 10 over 3 pi is equal to 12. And then I'm going to divide by this as well. So I get that R cubed is going to equal 12 divided by 10 over 3 pi. Now, at this stage, it doesn't really matter. I can basically just put that whole thing into my calculator now. I don't really need to worry about an exact value for this particular one. But I suppose if I was going to do it, it would be 36 over 10 pi. Because remember, dividing by a fraction is the same as timesing by the reciprocal. So if I've got 12 over 10 over 3 pi, that's the same as 12 over pi times by 3 over 10, like that. Is that just like a little side note there? Okay, so let's work out what this is going to be. So this is going to be 36 divided by, let's put the bracket thing in, 36 divided by, whoops, just show you what we're doing. So like 36 over 10 times pi. 36 over 10 pi is that. Okay, so 1.14. So R cubed is equal to 1.14591. So R is equal to the cube root of 1.14591. So let's get the cube root of that answer. So cube root of answer gives me 1.0464. So let me write that down. So R is equal to 1.0464. And the units are meters. Okay, so that's our value of R. Let's just round that to 3 significant figures. So R is equal to 1.05 meters to 3 significant figures. And hopefully you can see that was like, I thought, it seems a lot more straightforward than what we did in part A. Real nice, I think, comparatively easier 4 marks there. Okay, that's good. We're getting through this question now. We're almost finished with it. So the next bit, last bit for 2 marks, it says, calculate the minimum surface area of the tank, giving your answer to the nearest integer. Okay, so now that we found that the minimum value occurs when R is 1.05, all we need to do now is just take that and sub that value into our expression for our surface area. Okay, so we're going to sub that in order to find out what we get. So our surface area minimum, this is now part C, is equal to 12 over the 1.0464 plus 5 over 3 pi times by 1.0464 squared. Okay, and when we put that in, we find out that that gives us our minimum is actually equal to 17.20 meters squared. We have to be careful. It says give your answer to the nearest integer. Okay, so if we're giving this to the nearest integer, that is going to be 17 meters squared to the nearest integer. Okay, and that is an example of a differentiation optimization question. I hope that you found that useful, and I will see you in the next video.